Hi, I'm Chris Chafe, and I'm pleased to present a talk about musical performance during this period of the COVID pandemic. Very honored to be able to take your time to go through this description of events recent and history past. Starting with an email that I got about halfway through the pandemic, had this picture attached to it. And I find this, well, first of all, I thought it was a gag. I thought somebody had photoshopped it. But indeed, these are actually players inside little tents. I think the tents look like metronomes. So it's a bit indicative of the predicament. You can't be playing, in a room where you're going to spread particles. But you want to be able to play together, play in time. That's where I thought maybe these green metronome-looking things were the joke. But no, indeed, this was the real thing. And, if this is 2021, let's go back 20 years. This is the cover of the ACM organization magazine, Association for Computing Machinery. And we'd been at work on the predecessor to Jack Trip for about a year when I saw this and thought, hey, this is great. I'll open the magazine up and see how you do this, because wouldn't it be neat to be able to play together from a distance? So again, sort of in an inspirational relationship to this project that we're going to go into detail about, take a look at that conductor. Absolutely. That's one of the challenges that we'll talk about. So incidentally, there was nothing about music in this issue in the magazine, so we had to go on to work on it ourselves. I'd like to play a little bit of music at this point, just from last week, and that'll give us a chance to see what actually has been going on during this period. An excerpt from a live concert. This was the closing concert of the wind section of the Stanford Symphony Orchestra. In all of this work, I want to make it clear that there have been just so many contributors and ideas coming in, labor, sweat, coding, logistics, in order to wire up all of the Stanford musicians from home. We built Raspberry Pi-based kits with network sound, very similar to ideas which are going on now in the Jack Trip Labs and Jack Trip Foundation. We'll see a bit more about. I did 20 years worth of work in this project, along with teams and of students and staff at the Center for Computer Research and Music Acoustics at Stanford, Carmo. But just prior to the lockdown, I was spending the winter at the TU in Berlin and the Politecnico di Torino. Recently, at the invitation of the Hasso-Plattner Institute, we gave a talk on this, and I'm going to excerpt some of that. So thanks to the HPI folks for having us. But above all, it's the musicians who've provided, the experimentation, the will to find out what matters, and we'll now hear some more from them.
We're ready.
All right, gang, here we go. This one's just for us now. Ready?
That was the composition Sing Gently, conducted and composed by Eric Whitaker, with 3 choirs in California up and down the state, recorded a couple weeks ago in a live concert. Mike Dickey will talk a little bit about how these choirs came to start using Jack Trip over the past year, and the Raspberry Pis and the hub servers in the cloud.
My name is Mike Dickey. I am relatively new to the Jack Trip project. A year ago, I hadn't even heard of Jack Trip yet. So I'm certainly the newest person on board. And the way that I came to Jack Trip was by my son's boys chorus. He's been singing with the Ragazzi Boys Chorus in the San Francisco Bay Area for the last 6 years or so, which is more than half of his life. And I've been on the board for the past 2 years. And when we had to shut down the rehearsals for all of the boys, I saw them practicing on Zoom and realized that, they can't sing on Zoom. What they could do is kind of see each other's faces and try to have some connection through that platform. And I felt like there needed to be something better that we could do that was out there. And so I started looking at what technology options existed, really at the time having very low expectations of what could be done, and just hoping that we could have something that we could find that would create a stronger connection between the boys during the time of the pandemic, at least enough to keep their interest in music alive and to keep their connection and keep Ragazzi itself as an organization alive as a boys chorus. What I did is a bunch of scale testing on Jack Trip early on in the process to try to understand how many boys could we get feasibly online singing together, aiming for the entire membership of the 200-person boys chorus, but expecting that was completely unrealistic. So I started, and in my past life at Splunk, I ran their performance engineering team. So I had a lot of experience using cloud computing to do large scale testing. And I started spinning up a lot of servers and spending a lot on my AWS bill, and was able to simulate up to 500 simultaneous simulated musicians connecting to a single Jack Trip server at the same time.
Here's a short demonstration of the original project that predated Jack Trip. It was called Soundwire, sound waves on the internet from recirculating echoes. The idea that you could pluck the internet, much like you could pluck a stringed instrument. Here I've got, my handy dandy cello with a vibrato and a pluck tone. So what are you hearing? Well, you're hearing an excitation to a stretched string. This impulse travels back and forth very rapidly up and down the string. That's the acoustical medium for this instrument. It's attached to a bridge and a body, and it goes out into the air. But essentially, it's that recirculating excitation up and down the string that gives the pitch. So what if we could set up a recirculating excitation across the internet, where the delay in the round trip on the internet gives the pitch, just the way the delay up and down this string at the speed of sound on the inside the string material gives a pitch too. So that's what's set up here. I have a contact mic. That's my plucker, handily attached to the wall. If I bang on it, that is the impulse going to Stanford from my house, looping back from Stanford. And we pick it up here and we recirculate it. We let it go both directions. So let's see, where's the pitch today? So just shy of the E above my C string. And I'm doing vibrato here. Well, if we had really good jitter that was very regular, we'd get a vibrato. But this is a very plain tone, kind of straight. Oh, and you hear the pitch went up a little bit. And that's because the path changed ever so slightly. Going up a bit. Yeah, almost to the F there. So that was a recreation of a project from around year 2000. We started to use the same streaming technology for the SoundWire plucked network, the same technology to start playing together for gigs. And those were bidirectional, but only two-sided. So by some point, and this was 2004, we decided to try to make a three-way. And we'll hear a clip from across Western North America. This is a group, Gabe Davis on electric bass in Stanford, Charles Nichols on electric violin in Missoula, Montana, and Ajay Kapoor on sitar and tabla in Victoria, British Columbia. It's also where Jack Tripp got its name. Jack Audio Connection Trip, Jack Audio Connection Kit, triple or three-sided connection. Listen to the packet loss. It's almost like a guitar effect. It's from missing packets being replaced by the last good packet in a loop. And it's a wavetable, basically. There it is again. So this is Research Networks in the year 2004, connecting 3 universities. So the folks playing the music there, the musicians had never met before. They traded lead sheet over a PDF that they created together. It's kind of a harbinger, I think, of how everything we can do online is going to happen to go online. I'm going to play another clip now, which is from 2009, so 5 years later, with a large group of musicians across Canada, 3,000 kilometers apart. This is the composition, The Thing, by Don Cherry. And I'll cut it off there, but as you can see, the accelerando is a great test of lag or latency, and these musicians fearlessly went all the way to a concert with an audience, even though it was probably about like a over 30 millisecond one-way discrepancy. In 2003, we attempted to look at just what the effect might be of lag on rhythmic synchronization. We had a sort of test rhythm that we had people clap together, and these were volunteers or study subjects who had been positioned in two studios, separate rooms where they couldn't see each other, and just clapping this rhythm with headphones on. And we manipulated the time delays between the clapper A and clapper B, and took lots of measurements on tempo stability. This is a compendium of all of the trials, and I'm going to play what it sounds like at the lower delay. This is the second panel, and you'll hear the rhythm. And it keeps together pretty good at a couple of milliseconds. Now, the worst case in the bottom right, 78 milliseconds, one-way delay, deteriorates.
Sean?
What?
Are you having trouble, like, I'm just wondering if there's something going on.
So we had to actually change the protocol of the experiment and tell the subjects that it wouldn't be necessarily the fault of their randomly assigned partner that didn't know how to clap. Here's the work Juan Pablo Caceres did on modeling this idea of two, let's call them coupled oscillators, but they're musicians who are clapping. And you can see that as delay increases across the x-axis, tempo deacceleration occurs, and it's almost a perfect regression. You know, as you go higher in delay, you get more deacceleration. Interestingly, there's an intercept at 0 where 0 acceleration doesn't happen at 0 delay. It happens around 11 or 12 milliseconds. So we're there may be something intrinsic about anticipation or something, which wasn't the subject necessarily of the analysis in Caceres' dissertation. What you do see is some plateaus around that green line, which are, discussed as being adaptation strategies to greater and greater delay. And then at the time when this was finished work for Juan Pablo's PhD, he had modeled, sort of with the best synchronization science available at the time, a attempt to model the human behavior. Since then, and this is 2020 now, I'm going to look at another model of anticipation by Eran Roman, another PhD at Karma. And you'll see the same regression line and human data in the bottom left. That's graph B. And then you'll see with Eran's model that he approaches the human tendencies pretty closely, and this is with a generalized mathematical model. This doesn't really do anything with an attempt to model biological processes or anything more than just pure coupled oscillators, actually. Another 2020 study on large numbers of humans together in networks is fascinating, from Stony Brook University, and this was a group of electric violinists who were facing outward from each other, playing together, and then in different sort of meshes of delay and who hears who. What turned out was there was a lot of dynamics leading to chaotic behavior in their rhythms and tempi. For something really tight, though, this is the opposite of chaotic, and this has all the expression and pull and push on tempo that you could ever want in live performance. Dan Tepfer and Christian McBride. Dan Tepfer and Christian McBride connected across Manhattan using Jack Trip. Mike Dickey will explain a little bit about the virtual studio system with cloud servers and devices that can be run from home to connect large numbers of musicians. I'll also talk about this 25 millisecond thing for rhythmic synchronization.
And from here, the first thing you'll see is basically a page saying to register your device. You just click through a form, you register the device, and once it's there, you can select a server to connect your device to. There's also a servers page, which allows you to browse all the servers that you're managing or that are public. There's a whole lot of public servers. I have this one that I use for testing, Mike's Jam Room. You can choose the location from the region dropdown, and here you can see all the 53 locations. And if I choose Frankfurt and start, I can start up a server. Interesting from the sizes, you select the size of server based on the number of musicians that you anticipate connecting. And so of what is 25 milliseconds actually look like from a distance perspective, it's about 7,500 kilometers. So light can travel about 7,500 kilometers in 25 milliseconds. And so I tried to kind of put that into perspective in my head. If you look at the distance, excuse me again, from Dublin, Ireland to Tel Aviv, it's about 5,500 kilometers. So if you're thinking just in terms of the speed of light, well, you should be able to go anywhere in Europe in under 25 milliseconds, no problem. That's kind of what's theoretically possible. I don't think we'll ever get past the speed of light barrier, but theoretically, this distance is very big, and even with the footprint that we have today, the 53 locations, we could cover the vast majority of the world's population.
We haven't spoken yet about the problems of conducting or coordinating through video because there are problems, and they come from the much greater lag that you get in the video transmission compared to the audio. So back to Paul Phillips and the Stanford Symphony Orchestra recently.
What happens when everybody claps when they see the downbeat? And that's why I ask the musicians not to pay too much attention to me, because it's just everybody's visual rate through Zoom, because we're seeing each other through Zoom, even though we're hearing each other through Jack Trip. The rates are so different that if everybody tried to play off the visual beat, it would just be a mess all the time. And that's why you hear these taps as our starts to each movement, or almost each movement, because we're much more together working off of a audio cue than off of a visual cue.
The video problem can be overcome by sending uncompressed video or very lightly compressed video in a way that gets across faster and more in sync with the audio. And there's some other solutions besides Jack Trip which are out there, some of which include this very low latency audio like the Lola project, also UltraGrid project. And here's a table to compare what's currently mentioned in an article that's coming out. This is specifically about audio, but you'll see some of the names that I just mentioned. Jack Trip itself is going through a continual evolution. We are now about to release version 1.4.0, about 6 months after a lot of work went into the kind of mid-pandemic 1.3.0. The new one has a graphical user interface which runs handily on all platforms. This is the Linux, here's the Mac, here's the Windows. I'm going to close with some thoughts about the fact that we are creatures who have evolved to live in an acoustical medium which involves delay. I mean, everything about our lives in our environment involves, probably often very subtle amounts of delay, but nevertheless something that is really a part of our substance of being. And, whether it's music or orientation in space, delay is a part of our experience. And I think, it's been manifest more today in a way that we appreciate its effects on musical interaction and even just interaction with the notion of being able to have empathetic communication with others. So, if anything, we've sort of learned that now is a moment where telecommunications can intervene, and we can start to live in an acoustical medium, which also it has its own aspects of delay, but we can build it out in a way which, is more and more in the service of those kinds of things as, that we do as humans, and particularly in our artistic lives. Thanks for listening. Enjoy the rest of the conference.